Okay, welcome to the formula writing additional practice review. We've gone over formula writing a little bit in class. This is just some additional problems to kind of give you of me going through it so that you can hopefully feel comfortable with nomenclature. This is just going to focus on formula writing. I've got another one where we're coming up with the names of stuff. So a lot of formula writing is based on you having your polyatomic ions down pat. So that's one of the things that we're going to be reviewing here. So iron to carbonate, writing the formula for that. Well, hopefully you can realize that this is an ionic compound because it's got a metal in it, iron. And the way that we write the formulas for ionic compounds is via charge cancellation. Charges have to balance. Overall formulas have a charge for ionic compounds have a charge of 0. So first up is iron 2. The 2 means that the iron has a +2 charge. And then carbonates. Again, if something ends in ate or ite, if we've got that T ending, it's going to be a polyatomic ion. So carbonate, that's one of the ones that I am asking you to memorize. Carbonate, CO3, with a charge of -2. You've just got to get these things down. Got to get them in your heads because you've got to feel very comfortable doing this. Crisscross method here. Take the charge, make it the subscript for the anion, take the charge of the anion, make it the subscript for the cation. But this is also about getting charges to balance. So if you look at this, hopefully you can see that the iron is +2, the carbonate is -2. They're going to exist in a 1-to-1 ratio, so the formula is just FeCO3. Charges have to cancel one another out. Next up, potassium nitride. Again, this is a ionic compound because we've got a metal. So potassium is K. Now charge is not indicated. That means that there's only one possible charge for potassium. Where is potassium on the periodic table? Because that's going to help tell us its charge. It's in group 1. All the elements in group 1 have one valence electron. That means that its charge is +1 because it's going to lose that one valence electron, have an overall charge of +1. Next up, nitride. All right. Ide ending. It's not a TE ending. That means that 99% of the time it's going to be a single element. Well, what single element is it? It's nitrogen. Nitride, oxide, fluoride, chloride, etc., etc. It's nitrogen. What's the charge on nitrogen? Again, you go to the group number. You go to its position in the periodic table. Nitrogen is in group 15. That means it's got 5 valence electrons. Its charge is going to be based on getting to an octet. So we're going to have it gaining 3 valence electrons going from 5 to 8. So its charge is -3. Potassium is +1. Nitrogen is -3. Do the crisscross method. We're going to need 3 potassiums to balance out the -3 on the nitrogen. So the overall formula is K3N. Next up, silver phosphite. Again, this is just practice. Silver, Ag. No charge indicated. That means in terms of Roman numerals, that means that there's only one possible charge. I asked you to memorize that silver has a charge of +1. So that is something that you're going to have to know. Now, it's a transition metal, so this is not something that you can necessarily pick up from its position in the periodic table. When we get a little bit later in the year, you'll be able to see why silver is usually always +1. But for now, I'm simply asking you to memorize it. Phosphite. We have a TE ending. That means that it's going to be a polyatomic ion. So it's an ite ending. Ite, remember, means 1 less oxygen than 8. So you need to think. Phosphate. What's phosphate? This is what you should be thinking. This is your thought process. Phosphate. I asked you to memorize phosphate. I asked you to memorize that phosphate is PO4 3-. Okay, so you've got that in your head as something that you've memorized. Now we go to our rules. Ite means 1 less oxygen than 8. So instead of PO4, phosphite is going to be PO3. Charges stay exactly the same. It's the oxidation state of the phosphorus that's changing, maintaining that overall -3 charge. So Ag +1, PO3 3-, because ite means 1 less oxygen than 8. Balance the charges. I'm going to need 3 silvers to cancel out the -3 from the phosphate. Again, crisscross method is where I'm getting that. So Ag3, PO3. Next up, sodium cyanide. Sodium, Na. What's its charge? Where is it in the periodic table? It's group 1. Its charge is going to be +1. Cyanide. Now, here's one of those exceptions because usually you want to be thinking individual element, but cyanide is a polyatomic ion. I asked you to memorize it. So this is just going straight to your list of memorized ions. Cn, that's the cyanide ion. Its charge, again, something else you need to be memorizing, -1. +1, -1, charges already cancel one another out. Sodium cyanide is NaCN. Ammonium oxide, ammonium, ammonium, NH4+, polyatomic ion. Always tends to trip kids up because they tend to be thinking, oh, it's an element. No, it's not. It's a polyatomic ion. So make sure you know ammonium is NH4 + 1. Oxide, just like the nitride example right here. Oxide with that "ide" ending, it's based on an individual element. What element? Oxygen. What's the charge on oxygen? Look at its place on the periodic table. Group 16, 6 valence electrons, wants to get to 8, so it's going to gain 2 more. Charge of -2. I'm going to need 2 of the ammoniums to cancel out the -2 from the oxide. So the formula, putting that in parentheses, NH4,2O, ammonium oxide. And the last one, calcium hypoiodite. Well, calcium's easy. That's just Ca. Position on the periodic table tells you its charge. It's group 2, so it's going to be +2. Hypoiodite, perhaps not as easy. This is the thought process I want you to go through. I want you to see, first of all, that it's going to be a polyatomic ion. Hopefully that's evident from the fact that it's got a prefix indicating polyatomic ion and a suffix, the "ite" ending, that's going to indicate a polyatomic ion. Well, what polyatomic ion? Okay, let's focus on the iota. This means halogen. And whenever we think halogen, I want you to think chlorine. I want you to go back to chlorate. That is the halogen polyoxy ion that I wanted you to memorize, meaning it's got the halogen and the oxygens in it. Chlorate is ClO3 -1. That should be the first piece of information that you pull up in your head. Chlorate is ClO3 -1. That means that iodate, just swap out an iodine, is IO3 -1. Right? Because all halogens behave exactly the same way. So if chloride is ClO3 -1, iodate is IO3 -1. All you're doing is swapping out that iodine for a chlorine. Great. Now let's deal with the other parts of it. We've got the hypo and we've got the ite. Let's take the ite first. Ite means 1 less oxygen than 8. So iodite would be IO2 -1. But we don't just have ite, we also have hypo. Remember, hypo meaning hippo, not a lot of energy, moving very slowly, meaning even less oxygens. So hypoiodite is going to be 1 less oxygen than iodite on its own. So it's actually going to be IO with a charge of -1. Charge stays the same. Charge does not change in this ite-8 hypoite per 8 series. So these are our 2 ions, calcium +2, hypoiodite -1, balance the charges, we get CaIO2. Next up, acids. There's usually some problems writing formulas for acids. So hydrobromic acid. First of all acids are going to start with H. So we're going to know that, H +1. But we do need to balance charges, so it really essentially becomes about figuring out what is the anion in the acid, and then we can figure out how many H's we need. So hydrobromic acid, hydro. So, if we see that prefix hydro, it means that it is a binary acid, meaning just 2 elements, H and X, whatever the other thing is. Hydro means binary. So hydrobromic acid means that there's just hydrogen and then, well, bromic, what's that going to be? That's going to be Br. What's the charge on Br? Position in the periodic table, group 17, 7 valence electrons. It's gaining 1. So we've got the bromide ion, we've got the hydrogen ion. Balance the charges. Hydrobromic acid is HBr. Next up, sulfuric acid. You'll notice there is no hydro here. No hydro, so this is based on a polyatomic. Okay, so based on the polyatomic ion, that means that we need to look at the ending. This is sulfuric acid. Us came from ite. So sulfuric acid came from the sulfite ion. So what's the sulfite ion? I didn't ask you to memorize it, but I did ask you to memorize sulfate. Sulfate is SO4, -2. Sulfite, ite, means one less oxygen than 8. So sulfite is SO3, -2. Now we need hydrogen. Hydrogen is H plus 1. I've got these in the wrong order. I'm going to switch it around to put them in the correct order when I write the formula. I'm going to need, again, balancing charges. I'm going to need 2 hydrogens to cancel out the -2 charge of the sulfite ion. Sulfuric acid is H2SO3. Us comes from ite, sulfite, SO3 2 minus, balance out the H's. Next one, this is not periodic acid. That is not what it is. It is per-iodic acid. Per-iodic acid. No hydro prefix out in front, meaning it's from a polyatomic ion. What polyatomic ion is it from? Look at the ending. Ic comes from 8. And not only do we have ic, we have per. So this is per. Ic comes from per 8. So we need to think. This is coming from the per-iodate ion. What's the per-iodate ion? Go through the system. Think chlorate. Chlorate is ClO3 -1. Okay, that's chlorate. Great, but we've got iodate here. So iodate is IO3 -1. Swap out the halogens. That's really easy. All right, well, iodate is IO3 -1, but we don't have iodate. We've got per-iodate. Per comes from hyper, meaning more. So per-iodate ion is IO4, one more oxygen, but keeping the charge exactly the same, IO4 -1. It's an acid. That means that we also have H plus as the cation. Balance the charges, H plus 1, IO4 -1, HiO4. That would be per-iodic acid. Next up, Cloris acid. No hydro, not binary, polyatomic ion. Okay, so now we're thinking us. Us comes from ite. So chlorite, what's chlorite? Well, it comes from the chlorate series. Okay, chlorate series, ClO3 -1, that's chlorate. Ite means one less oxygen than 8. Chlorite is ClO2 -1. This is an acid. So our cation is H plus. Combine them, H plus 1, ClO2 -1, HClO2. Next up is carbonic acid. There is no hydro out in front. It is not binary. It is based on a polyatomic. So then we look at the ending. Ic, it ends in ic. Ic comes from 8. So we need to think, what is the carbonate ion? I asked you to memorize that. That's one of the ones that you just have to have down. You got to have it down, got to have it down. Carbonate ion is CO3 with a charge of -2. Hydrogen is +1. So when we do the crisscross method, H plus 1, ClO3 -2, I'm going to need 2 hydrogens to balance out the -2 charge. Carbonic acid is H2CO3. Last one, hydrofluoric acid. Here's where kids tend to get a little confused because they get really awesome at remembering that ic comes from 8, but what they're not seeing first up, hydro, prefix hydro. Prefix hydro means binary, binary acid. That means that there are only 2 elements in this acid, H plus and something else. Well, what's the something else? Right here, fluoric. That means something else is fluorine. So F, figure out the charge. Where is F on the periodic table? Group 17, 7 valence electrons. It needs 8, so it's going to gain 1. So its charge is -1. Crisscross them, HF. That's hydrofluoric acid.